Hi students, welcome to physics classes. Now we will discuss an activity on the topic of heat. Activity to show rate of rise in temperature depends on nature of material. Now whenever we are supplying amount of heat to a body, its rise in temperature depends on nature of material. Different materials will take different times to raise its temperature, so that we can prove with the help of an activity. Rate of rise in temperature depends on nature of the material. To do this activity, we need a large jar and two identical boiling test tubes. Next, two single holed cork. This is the cork. Two single holed corks and two thermometers, two stands. Once again, what we require? One large jar, two test tubes, boiling test tubes, two corks which are having a hole, two thermometers and two stands. And in this large jar we should pour some hot water which is at temperature of 80 degrees Celsius, higher temperature, and in two test tubes, one with water at room temperature, another one with oil at room temperature. These are the materials we need. Now here, why we are taking these materials? Here we have taken hot water and two test tubes are filled with oil at room temperature, another one is water at room temperature. So both are having same temperatures, both are equal volumes we have taken. Now whenever we place in the hot water, heat will be transferred to both of them equally. So we can observe the rise in temperature. We can observe the rise in temperature. First we should take a large jar. More than half of the vessel is filled with water at higher temperature. Now it is 80 degrees is not fixed. We can take 90 degrees also, more temperature. And we should take two test tubes. One is filled with water at room temperature, another one is filled with oil at room temperature. Both should be at same temperatures. Oil and water which are taken in test tubes should be at same temperature. Now both should be immersed in the hot water with the help of stands. And we should place two thermometers in that by using single holed cork. This is the procedure. Glass jar filled with hot water, two test tubes filled with oil at room temperature, water at room temperature, and placed in the hot water with the help of stands, and two thermometers are placed in it to measure the temperature. This is the procedure. Next, we should observe it for a few minutes. Now whenever we are observing, thermometer which is placed in oil, mercury level increases fastly when compared to water. Thermometer which is placed in oil, mercury level increases fastly when compared to the thermometer which is placed in water. So by observing that, we can say oil temperature is increasing fastly when compared to water. Rate of rise in temperature is more for oil when compared to water. Here we are giving same amount of heat with the help of water. We kept both are in hot water, so in the same time we are giving same amount of heat. But oil temperature is rising quickly when compared to water. So we can say rate of rise in temperature is more for coconut oil or whatever it is oil we have taken when compared to water. So we can conclude that rate of rise in temperature depends on nature of the material. Rate of rise in temperature depends on the nature of the material. Now, activity to find specific heat. To derive the formula for specific heat. Now, first we have taken two identical vessels filled with water. We can name it as A, B. Now, by seeing that the diagrams, we can say that it has more amount of water when compared to B. So mass of A is more when compared to mass of B. Let us take both are having same initial temperatures. Both are having same initial temperatures. So now I want to supply heat. Amount of heat is denoted with the letter Q for both A and B. I want to supply heat. Now A is having more mass, B is having less mass. But both are having same initial temperature. From that, I want to raise its temperature by 40 degrees Celsius. Example, 40 degree Celsius. From initial temperature to I want to change its temperature by 40 degrees Celsius. From initial onwards, I want to increase 40 degrees Celsius. But A is having more mass, B is having less mass. I want to increase same temperature for both. So I should supply some amount of heat. Then can you say which one we should supply more amount of heat? For which one we should supply more amount of heat? Obviously A. For A we should give more heat. To get same temperature. Why? A is having more mass. When A has more mass, we should give more amount of heat. To get same temperature, B has less mass, less heat is enough. But A has more mass, we should give more amount of heat. So here, amount of heat given to a body is directly proportional to mass. When change in temperature is constant. When temperature is constant, amount of heat given to a body depends on mass. If it is having more mass, we should give more amount of heat. If it is having less mass, we should give less amount of heat. That we can take equation 1. Now next we have two identical vessels. Both are having same amount of liquid. Masses are equal, A, B, two vessels. Its masses are equal. Both are having same mass. Both are at same initial temperature like previous. Same initial temperatures. Now, here again I am giving heat. By giving heat, I want to change its temperature for A by 60 degrees Celsius, and for B, change in temperature for B, I want to raise by 30 degrees Celsius. Both are having same masses. Both are at same initial temperatures. But by giving some amount of heat, I want to raise temperature of A by 60 degrees Celsius. I want to raise temperature of B by 30 degrees Celsius from their initial temperature. So for which I should give more amount of heat? Obviously for A. More heat is needed. Why? It requires, we want to change its temperature. More change in temperature. To change more, we should give more amount of heat when masses are constant. So from this we can say amount of heat directly proportional to change in temperature when mass is constant. When change in temperature is constant, it depends on mass. More mass, more change in temperature. When more mass, more amount of heat is required. When mass is constant, change in temperature, amount of heat depends on change in temperature. More change in temperature, more amount of heat. Less change in temperature, less amount of heat. This can be taken as equation 2. From equation 1 and 2, we can write amount of heat that depends on mass and change in temperature. Amount of heat that depends on mass and change in temperature. From this we can write Q is directly proportional to m delta T. To remove this proportionality symbol, we should take one constant that is equal to m s delta T. S is proportionality constant. We can say this is specific heat. We can say it is specific heat. From this we can write S equal to Q by m delta T. This is the formula for specific heat. This is the relation we require. S equal to Q by m delta T. Now SI unit of specific heat, as it is having formula S equal to Q by m delta T. SI unit of Q, heat, is joules by mass, kg, temperature, kelvins. CGS unit of heat, calorie per mass, gram, change in temperature, degree Celsius. Joule per kg Kelvin, calorie per gram, degree Celsius. Now, if mass of the body equal to 1 gram, unit mass of the body, if we want to raise its temperature by 1 degree Celsius, now if mass equal to 1 gram, that is unit mass, change in temperature 1 degree Celsius, unit temperature, then if you substitute these values in the specific heat formula, S equal to Q by mass is 1, change in temperature is 1, so we can write S equal to Q. By this we can say the definition of specific heat. From this, we can say the definition of specific heat. Specific heat of a substance is the amount of heat. Specific heat is equal to amount of heat when unit mass of the body to change its temperature by 1 degree Celsius. Specific heat becomes amount of heat when it is possible when the mass is unit and change in temperature is 1 degree Celsius. Then specific heat is equal to amount of heat. So we can write the definition of specific heat. Specific heat is the specific heat is the amount of heat required to raise the temperature of unit mass of the substance by 1 degree Celsius. Unit mass by 1 degree Celsius. That is, that amount of heat is known as specific heat. That amount of heat is known as specific heat. It is not always, only when unit mass by 1 degree Celsius. Okay, when mass is unit and its temperature, change in temperature is 1 degree Celsius, then amount of heat required is specific heat. Then amount of heat required is specific heat. Now, next applications of specific heat. We have some applications that related to specific heat. First one is water, ocean water. Daily we are getting more amount of heat from the sun. More amount of heat from the sun. That whatever the heat coming from the sun is absorbed by water and its temperature will not rise quickly. As we seen in previous activity, we given same amount of water, same amount of heat to water and oil, but oil temperature is raised, but water temperature is not raised because water has more specific heat. More specific heat, that equals to specific heat of water equal to 1 calorie per gram degree Celsius. This is the most. Now, as water is having more specific heat, it absorbs more amount of heat from the sun and it moderates the surrounding temperature. It moderates the surrounding temperature. That's why water is known as heat storehouses. Heat storehouses. Oceans are known as heat storehouses. So earth is covered by more amount of water. The heat coming from the sun is absorbed by the water and it will moderate the surrounding temperature. It will moderate the surrounding temperature. Next one is watermelon. Watermelon. Watermelon taken out from the fridge. It stays cool for more time. It stays more time with the same coolness. Even taken out from the fridge much time, it will be stays cool. That is because it has more specific heat. More specific heat. Next, samosa. Even we touch the samosa, outside it becomes cool, but inside ingredients will be hot because that ingredients which are used to prepare samosa having more specific heat. These are the 3 applications of specific heat. Next topic, activity for method of mixtures. Activity for method of mixtures. Now this activity for when 2 liquids of certain temperature are mixed, what will be the resultant temperature? What will be the resultant temperature? Now if you have 2 liquids whose masses are equal, both are having same mass and both are having same temperature. If we mix, what will be happen? Mass becomes double and its temperature is same. Because as we discussed earlier, heat travel from higher temperature to the lower temperature. But here both are having same temperature. So no transfer of heat. But result stays same. Result stays same. Suppose if you take two liquids of equal masses, two same liquids of equal masses whose temperature, for example, first liquid temperature is 40 degrees Celsius, second liquid temperature is 20 degrees Celsius, are mixed, then what will be the resultant temperature? What will be the resultant temperature? Now to say that both are having same masses, simply we can say 40 plus 20 divided by 2, that equal to 30 degrees. We can say directly average. Suppose two liquids are having different masses m1, m2, different masses and different temperatures. For example, it is having more temperature, it is having less temperature, relatively more temperature, less temperature. When compared to these two, it is having more, it is having less. Then what will be the resultant temperature? What will be the resultant temperature? Now here this body whose temperature is more will loses the heat energy. After mixing, heat will travel from higher temperature to the lower temperature. It is having more amount of temperature, so more heat, it will loses the heat energy and it will gains the heat energy. Amount of heat whatever it is losing, that will be gained by second liquid. For example, A, B, to avoid confusion. A will loses the heat energy because it has more temperature. B will gain the same amount what A will loses. That can be explained by principle of method of mixtures. Principle of method of mixtures. What it will say? What it will say is amount of heat lost by hot body is equal to amount of heat gained by cold body. Heat lost by hot body equal to heat gained by cold body. Same amount. Whatever the heat it lost, it will gain. That one we can write simply net heat lost by hot body equal to net heat gained by cold body. Net heat lost by hot body equal to net heat gained by cold body. Now, if mass of hot body is m1, mass of cold body is m2, temperature of hot body is T1, temperature of cold body is T2. After mixing, resultant temperature is T, that we are going to find. Now it will loses heat energy. Q equal to ms delta T is the formula for heat. To calculate amount of heat, Q equal to ms delta T. Now if we consider both are water, this is hot water, this is cold water, whose specific heat is 1 calorie per gram degree Celsius. So we need not to substitute specific heat value. So Q lost by hot body equal to Q gained by cold body. Now whose mass is m1, specific heat is 1, no need to substitute. Change in temperature. Change in temperature, initially it has higher temperature, after losing something it becomes T. So higher temperature T1 minus T, lower temperature, equal to gain cold body, mass m2, specific heat 1, change in temperature. Initially it has T2, after gaining something it becomes T. So higher temperature minus lower temperature. Now if you multiply m1 T1 minus m1 T equal to m2 T minus m2 T2. This minus m2 T2 coming this side and this minus m1 T is coming this side. So I am taking T to one side, this T1 T2 to another side. So m1 T1 minus coming this side becomes plus m2 T2 equal to m2 T, this minus coming this side becomes plus m1 T. From these two, if you take T common, m1 plus m2. Then if T is here, m1 plus m2 is coming this side, m1 T1 plus m2 T2. Here these two are multiplying, so T is multiplying with m1 plus m2. This m1 plus m2 coming this side, divided by m1 plus m2 equal to T. Then we can write T equal to m1 T1 plus m2 T2 by m1 plus m2. This is the mixture of two liquids of same nature with different masses and different temperature. So final temperature T equal to m1 T1 plus m2 T2 by m1 plus m2. This from this here for this activity we used principle of method of mixture. What it is? Net heat lost. Net heat lost equal to net heat gain. Who is losing? Hot body. Who is gaining? Cold body. Net heat lost by hot body equal to net heat gained by cold body. Thank you for watching. Please subscribe.